Today's class I will start with Fourier Transform. Before coming to the definition of Fourier Transform, we will know what is an integral transform. See, Fourier Transform is obtained from Fourier series. Let's learn what is integral transform. So, integral transform, from the name itself, you can understand that it will have an integral. So in transform means change. See, you have learned the transformation from Cartesian coordinates to polar coordinates. That is, if you have xy coordinates in Cartesian plane, you can write it in terms of r and theta in polar plane. So that is y equals f of x, equation of Cartesian curve. It can be transformed to r equals f of theta, that is equation of polar curve, using x equals r cos theta, y equals r sin theta. And you can also write r as root of x square plus y square, theta as tan inverse of y by x. So you have learned this in 11th and 12th and first year. So you know the transformation from Cartesian curve to polar curve. So how do you transform xy to r theta? X equals r cos theta, y equals r sin theta. And if you want to transform, if you want to get xy from r and theta, you will get r as, you will use r equals root of x square plus y square, theta is tan inverse of y by x. So if you know xy, you can get r theta. If you know r and theta, you can get xy. So that is in, now here we have integral transform. So we have learned the transformation from Cartesian plane to polar plane. So here we have the integral transform. So the integral, the definite integral alpha 1 to alpha 2 f of x k of sx dx is called as the integral transform. The definite integral alpha 1 to alpha 2, integral alpha 1 to alpha 2 f of x k of sx dx is called as the integral transform. So f of x is for the given function and k of sx is called as the kernel of the transform. So kernel is in your hands. You can decide the kernel. Um, and the kernel function is in your hands. You can decide the kernel function. So f of x is a given function. F of x is not in your hands, but kernel is in your hands. So this k of sx is called as the kernel of the transform. It is a function of s and x. So integral, definite integral x equals alpha 1 to alpha 2, f of x k of sx dx is called as the integral transform, where k of sx is called as the kernel of the transform. Now, when you integrate this definite integral, see, you have the integrating variable as x. You have the integrating variable as x, and s is the parameter or the constant. So, when you integrate a function of x with the limit substitution, it will become a function of s. It will become a function of the constant s. Say for if suppose, say for example, integral x equals 0 to a x dx. Suppose if I have the definite integral x equals 0 to a x dx, what do you get? X square by 2, that is a square by 2. X square by 2 from 0 to a is a square by 2. So it is a function of the constant a. So definite integrals are always solutions of the constants. So whatever be f of x, when you integrate, you will get some function of x with the limits, alpha 1 and alpha 2, it becomes a function of s. There is no substitution for s. S is fixed. So when you will be integrating only with respect to x, with the substitution of limits, the solution will be a function of s. That is why it is written as f cap of s or f cap of s. This is called as a transform function. F of x is a given function. F cap of s is called as the a transform function. So yeah, this is f of, if you do transform of f of x, if you find the right side, if you do the right side, you will get transform of f of x. That is IE of f of x. IE of f of x means integral transform of f of x. You will get it as a function of s. That is written as f bar of s. So f bar of s is the integral transform. And if you take the inverse, you will get back the function itself. F of x is called as the inverse transform. F cap of s is called as the transform function. F of x is called as the inverse transform. So if you have the transform, you will get back. You will if you have the transform, you can get back the function. If you have the function, you can find the transform. Just like addition and subtraction, if you know, if you have addition, the reverse operation is subtraction. Same way, if f of x is known, then you can find the transform. If you have the transform function, you can get back the function itself. So f of x is called as the inverse transform of f bar of s. F bar of s is called as the transform of f of x, integral transform of f of x, and f of x is called as the inverse transform. That is why you have the integral transform of a function is denoted by I of f of x. So if f of x is known, you can get the integral transform. If you can get back the function from f cap of s itself. So while doing problems, you will understand the difference. So as of now, you learn what is integral transform. So as I told you, kernel is in your hands. Laplace took the kernel as e power minus sx. So this integral became Laplace transform, and Fourier defined the kernel as e power I alpha x that is complex exponential function. So this integral becomes Fourier transform. I repeat, a kernel function is defined as e power minus x. Laplace defined the kernel as e power minus x minus sx. So it is called as a Laplace transform. Fourier took the kernel as e power I alpha x. It is complex exponential, so it is called as the Fourier transform. And Mellin took the kernel as x power I minus 1, so 1 becomes Mellin transform. So the transforms are named by the mathematicians and physicists. So if Laplace took the kernel as e power minus sx, Fourier took the kernel as e power I alpha x, Mellin took the kernel as x power I minus 1. So in this module, you are going to learn about Fourier transform. You will be learning Laplace transform later. So it's enough if you know what is integral transform in from this page. Now, before coming to the definition of Fourier transform, uh, I will explain how you are getting the formula for Fourier transform. See, the Fourier transform is derived from Fourier series. So what is Fourier series? Fourier series is for functions, continuous or discontinuous, periodic or non-periodic, as a trigonometric series. So any function, continuous or discontinuous, periodic or aperiodic, can be expressed as a trigonometric series. But Fourier, if you take, you have learned problems in Fourier series of period 2L and period 2 pi. So it is integral minus L to L, 0 to 2L, 0 to 2 pi, minus pi to pi. So you had only finite intervals. You didn't have infinite intervals. So in transform, instead of finite interval, you have infinite range. That is the difference. In Fourier series, you had only finite interval. 0 to 2L, 0 to 2 pi, minus L to L, minus pi to pi. But in Fourier transform is for infinite range, that is minus infinity to plus infinity. So, um, so before, so you take a Fourier series, and this is called as the Fourier integral theorem. Let f of x be a real valued function that satisfies a Dirichlet's condition in open interval minus L here, for which the infinite integral mod integral minus infinity to infinity mod of f of x dx exists. So f of x is a real valued function which satisfies a Dirichlet's conditions, for which the infinite integral exists. So, Fourier series, you know, that Dirichlet has given the conditions for Fourier series. Euler gave the formula for A naught, A n, T n, and Fourier expressed the function as a trigonometric series. So, it is a combined work of mathematicians and physicists, Dirichlet, Fourier, and Euler. So this is the condition. Then A of alpha is taken for is defined this way: infinite range. You see, integral minus infinity to infinity. B of alpha is defined this way. Fourier defined A of alpha, B of alpha as this integral, as its definite integrals. So f of t cos alpha t, you know that a non, what is a n? A n is always associated with the product f of x cos. Bn is also always associated with the product f of x sin. So there you had finite range minus L to L, 0 to 2L, 0 to 2 pi, minus pi to pi. So here we are talking about infinite range minus infinity to infinity. So Fourier fixed the Fourier defined the definite integrals as A of alpha, B of alpha. You see both the integrals. When you integrate with respect to t, it will be a function of alpha. Definite integrals are always solutions of constants. So when you integrate, you don't know f of t, but still you can say that it is a function of alpha. Similarly, here also f of t is not known. When you integrate this definite integral, it is a function of alpha. So b of alpha. So now integral, consider integral 0 to infinity a of alpha cos alpha x plus b of alpha sin alpha x. So we have this integral 0 to infinity a of alpha cos alpha x plus b of alpha sin alpha x d alpha. So where f of x is continuous at x, so we can show that it is equal to f of x, which is continuous at x. Now, this is Fourier integral theorem. I am just giving the outline of the definition of Fourier transform because the proof is very lengthy, runs 2 pages. So I will tell you in 2, 3 classes how we are getting the definition. You don't, it is not there in the syllabus, but still I'll explain what it is. So Fourier integral theorem says that this integral is equal to integral 0 to infinity a of alpha cos alpha x plus b of alpha sin alpha x d alpha is equal to f of x, which is continuous at x. So this is called as a Fourier integral representation. If f of x is discontinuous, you can write the averages. You can write it as average of left limit and the right limit. Now substituting for A of alpha and B of alpha, you know what is A of alpha and B of alpha. Here A of alpha is there, B of alpha is there. So substituting for A of alpha and B of alpha in this expression, you have in 1 by pi integral 0 to infinity, integral minus infinity to infinity, f of t cos alpha x plus sin alpha t sin alpha x dt d alpha. So this a alpha, b of alpha is substituted. A of alpha and b of alpha are integrals of t, are integrating variables with respect to t. So that is why you have f of t cos alpha x plus sin alpha t sin alpha x dt d alpha. So this is of the form cos A cos B plus sin A sin B. It is cos of A minus B. So cos alpha into t minus x. So what is cos theta? E power I theta plus e power minus I theta by 2. What is cos theta? E power I theta plus e power minus I theta by 2. That's so it is written, this is written as half of e power I alpha t minus x plus e power minus I alpha t minus x. Half is taken out. Then it is split into two integrals. So 0 to infinity integral minus infinity to infinity f of t e power I alpha t minus x dt, first integral. And here 1 by 2 pi 0 to infinity integral minus infinity to infinity e power minus I alpha t minus x dt d alpha. Now, in this, um, now changing alpha to minus alpha. So in this integral, alpha is replaced by minus alpha. So you have minus infinity to infinity. Um, e power minus I alpha, this expression, alpha is replaced by minus alpha. So the limits will change. 0 to infinity will become minus infinity to 0. When you replace alpha by minus alpha, 0 to infinity will become minus infinity to 0. That's what is written here. Minus infinity to 0, integral minus infinity to infinity infinity f of t e power I alpha t minus x dt d alpha. I repeat, this expression alone, alpha is replaced by minus alpha. When you do that, 0 to infinity becomes minus infinity to 0. When you replace a quantum alpha by minus alpha, the limit 0 to infinity will become minus infinity to 0. That's what is written here. So minus infinity to 0, this will be minus infinity to 0. Minus infinity to infinity f of t e power I alpha t minus x dt d alpha. I repeat, the first expression is no change. The second expression, alpha is replaced by minus alpha. When you replace alpha by minus alpha, 0 to infinity becomes minus infinity to 0. That's what is written here. And the rest everything is same. Minus infinity to 0, minus infinity to infinity, f of t e power I alpha t minus x dt. So you have minus infinity to 0. This is minus infinity to 0 and this is 0 to infinity. So minus infinity to 0 and 0 to infinity will become minus infinity to infinity, minus infinity to infinity f of t e power I alpha t minus x dt. See, you see the outer integral. This is 0 to infinity, and this integral has become minus infinity to 0. So combining the outer integrals, you will have minus infinity to infinity in the outside, the outer one, the outer integral, and inner integral there is no change. I repeat, this is minus infinity to 0. You see the outer integral, this is minus infinity to 0, and this 0 to infinity. Combining these two, the outer integral is minus infinity to infinity, and the inner integral there is no change. So then we are taking e power, we are splitting the exponential function. E power minus I alpha x is taken outside, and you have inside integral minus infinity to infinity f of t e power I alpha t dt. So this inner bracket is called as a Fourier transform. This in bracket term is called as a Fourier transform. It is denoted by f of alpha, and the outer bracket, the outer thing, the outer integral is called as the inverse Fourier transform. I repeat, the bracket term is called as the Fourier transform, and the outer integral is called as the inverse Fourier transform. So you are getting both transform and the inverse in the same expression. I repeat, the bracket term is called as the Fourier transform, and the outer integral is called as the inverse Fourier transform. So 1 by 2 pi is split as 1 by root of 2 pi into 1 by root of 2 pi. 1 by 2 pi is split as a product 1 by root of 2 pi into 1 by root of 2 pi. So the inner bracket, see this is the inner bracket, 1 by root of 2 pi minus infinity to infinity, f of t e power I alpha t dt is called as a Fourier transform. That is f of alpha, and the outer bracket 1 by root of 2 pi minus infinity to infinity e power minus I alpha x, the inner bracket is f of alpha, is called as the inverse Fourier transform. Now, so this is enough if you understand. You don't have to learn the proof for the definition. In exam, you will be asked only problems. So what is Fourier transform? Fourier transform is defined as f of alpha 1 by root of 2 pi integral minus infinity to infinity f of t e power I alpha t dt. So this one is called as a Fourier transform. 2 is called as the inverse Fourier transform. What is the inverse Fourier transform? F of x equals 1 by root of 2 pi integral minus infinity to infinity f of alpha e power minus I alpha x d alpha. You by heart these two formulas. Your syllabus starts with this first expression f of alpha 1 by root of 2 pi integral minus infinity to infinity f of t e power I alpha t dt is called as the Fourier transform. Second expression f of x equals 1 by root of 2 pi integral minus infinity to infinity f of alpha e power minus I alpha x d alpha is called as the inverse Fourier transform. So by heart these two. So Fourier transform is denoted by f of alpha. Why f of alpha? You are integrating with respect to t. Definite integral. It is a function of the constant alpha. That is why you have f of alpha here. I repeat, it is a definite integral. Definite integrals are always solutions of constants. So alpha. So f of alpha. And here, alpha is a variable and x is a constant. So this is definite integral is a function of x. I repeat, definite integrals are always functions of constants. So here t is the variable, alpha is a constant, so f of alpha. Here alpha is a variable, x is a constant, so f of x. So Fourier transform is denoted by f of alpha, f of x, or f cap of alpha. Inverse Fourier transform is denoted by f inverse of f of alpha, or f inverse of f of x, or f of x. I repeat, Fourier transform is denoted by f of alpha, capital f of x, or f cap of alpha. Ft means Fourier transform. Inverse Fourier transform is denoted by f inverse of f of alpha, or f inverse of f of x, or f inverse of f cap of alpha, or f of x itself. So this, I'll tell you one example. See, I am giving a lecture. If it is confined to one class, if it is restricted to only 60 students, it means Fourier series. But if it is delivered to whole world, it becomes Fourier transform. I repeat, if my lecture is listened only by a group of 60 students, limited audience, it is Fourier series. But if it is listened by infinite audience, it is Fourier transform. Now we will get into the properties. A property is a Fourier transform. First one, linearity property. See, any concept you take, you will have the basic operations, addition. Say, for example, you had numbers, from numbers you have basic operations, addition, multiplication, subtraction, division. Even in algebra, you had sum of two variables, product of two variables, multiplication, division. Same thing, here you have linearity property. So, sum of the transforms of two functions. So for any constant, the property states that for any constants a and b, f of a f of x plus b g of x equals a times f of x plus b times f of g of x. What is f? Fourier transform. Fourier transform of the sum a f of x plus b g of x equals a times the transform of f of x plus b times the transform of g of x. What do you mean by this expression? Capital F for Fourier transform. Fourier transform of this sum a f of x plus b g of x is equal to a times the transform of f of x plus b times the transform of g of x. So let us start with the definition. F of x or f of alpha is defined as 1 by root of 2 pi integral minus infinity to infinity f of x e power I alpha x dx. Start with the definition. This is a definition of Fourier transform. A transform will have two notations. One with respect to variable, that is x, so f of x. Other with respect to the parameter alpha, that is f of alpha. I repeat, any transform will have two notations. One with respect to the variable x and other with respect to the parameter alpha. So f of x or f of alpha, they both mean the same. So in place of f of x, you have a f of x plus b g of x. This is a definition of transform. In place of f of x, you have a f of x plus b g of x. So what the definition says, 1 by root of 2 pi integral minus infinity to infinity. In place of f of x, you have a f of x plus b g of x. Kernel is fixed. What is a kernel? Complex exponential e power I alpha x dx. There won't be any change in the kernel. Kernel is decided by Fourier. You will be given the function. You are finding only the transform of f of x. Kernel is same in all the concepts. So this will not change. Exponential function, this complex exponential will not change. So in place of f of x, a f of x plus b g of x. So 1 by root of 2 pi integral minus infinity to infinity. In place of f of x, you have a f of x plus b g of x e power I alpha x dx. Then split into two integrals. So a and b are constants. So a is taken out. a times 1 by root of 2 pi integral minus infinity to infinity f of x e power I alpha x dx plus b times 1 by root of 2 pi integral minus infinity to infinity g of x e power I alpha x dx. So I have split into two integrals, and remember any transform will have two notations, one with respect to the variable, other with respect to the parameter. So if you are given the integral, you should know to write the left side. If you are given the left side, you should know to write the right side. So you should remember both the ways. I repeat, you remember this equation, this formula. If you have f of x, you should know to write the right side. If you have the right side, you should know to write the left side. So from right side, how do you write left side? With respect to variable, that is f of x, or with respect to the parameter alpha, that is f of alpha. So what is this term? A times Fourier transform of f of x. What is the function here? F of x. B times Fourier transform of g of x. So I have written with respect to the function. A times what is the variable? Fourier transform of f of x. B times f of g of x. Now, if you are writing with respect to parameter, it will be f of alpha, or here it will be g of alpha. Since there are two different functions, we are having f of alpha and g of alpha. I repeat, these are in Fourier, this is the formula. You have two notations. You are writing left side from right side. So from right side, how will you get left side? Either with respect to the function or with respect to the parameter. So if you write with respect to the function, a times f of x, and here b times f of g of x. So, so it is a times Fourier transform of f of x plus b times Fourier transform of g of x. Otherwise, if you are writing with respect to parameter, a times f of alpha plus b times g of alpha. Why I am writing g of alpha? Because f of x and g of x are two different functions. So hence the statement. So transform of the sum a f of x plus b g of x equals a times the transform of f of x plus b times the transform of g of x. So if from this, if you take inverse, if you take the inverse of right side, take f to the right side. So f inverse of a f of alpha plus b g of alpha equals the bracket term. That is a f of x plus b g of x. I repeat, if you take inverse of the right side, f inverse of a f of alpha plus bg of alpha, you will get the bracket term, that is a f of x plus bg of x. Now we will see the second property, change of scale property. So scale means scalar thing. So A is what is change of scale property? F of Ax, that is transform of the function f of Ax equals 1 by A f of alpha by A. Transform of the function in Ax equals 1 by A f of alpha by A. So A is replaced by 1 by A. That is why you call it as change of scale property. A is replaced by A, that is why we call it as change of scale property. So what is, let's start with the definition. What is the definition of Fourier transform? F of x equals 1 by root of 2 pi integral minus infinity to infinity f of x e power I alpha x dx. So I told you there are two notations, one with respect to the function f of x, or with respect to the parameter f of alpha. So start with the definition. And what is asked? In place of f of x, you have f of ax. In place of f of x, you have f of ax. So just replace f of x by f of ax. So 1 by root of 2 pi integral minus infinity to infinity f of ax e power I alpha x dx. Then we are doing the substitution. T is ax. So a is a constant. So dt equals a dx, or dx equals 1 by a dt. So as x varies from minus infinity to infinity, x varies from minus infinity to infinity, t will also vary from minus infinity to infinity. Ax is t, so f of t, e power I alpha, what is x? T by a. E power I alpha, what is x a? T by a. And what is dx? 1 by a dt. I repeat, we are taking t as ax. A is a constant. So dt equals a times dx, or dx equals 1 by a dt. So we are replacing this integral in terms of t. We are rewriting the integral in terms of t. So 1 by root of 2 pi integral minus infinity to infinity f of t e bar I alpha. What is x? T by a. Dx is 1 by a dt. And the next step, you take 1 by a out, 1 by root of 2 pi integral minus infinity to infinity f of t e bar. Alpha and a are constant, so I have grouped alpha by a t dt. I repeat, 1 by a is taken out. 1 by root of 2 pi integral minus infinity to infinity. T is the variable, so f of t e bar I alpha. Alpha and a are constant, so they are written, they are grouped e bar I alpha by a t dt. So now you see this is the same as the definition of Fourier transform. You compare these two integrals. If in place of alpha, you have alpha by a. You see this definition. X, x is a constant, alpha, sorry, x is a variable, alpha is a constant. Here, t is the variable, alpha by a is a constant. You see the definition, x is a variable, alpha is a constant, and here t is the variable, alpha by a is a constant. So if alpha is a constant, it is written as f of alpha. If alpha by a is constant, then it is f of alpha by a. I repeat, you have seen the definition. um, X is a variable, alpha is a constant. So what is the notation? Capital F of alpha with respect to the constant, capital F of alpha. But here you compare these two, you have 1 by root of 2 pi integral minus infinity to infinity f of t e power I alpha by a t dt. So in place of x you have t. In place of alpha you have alpha by a. T is the variable here. So if alpha is a constant, it is f of alpha. If alpha by a is a constant, it is f of alpha by a. So it is the change of scale property. F of ax is 1 by a, f of alpha by a. So this is the second property where a is positive constant. So this condition is very important. If a is 0, it becomes infinity. Because a is positive constant. If a is negative also, it will affect the definition. That is why a is taken as positive. The scalar a is replaced by 1 by a. That is why we say change of scale property. Then we have the shifting properties. F of x minus a equals e per ia alpha f of alpha. Okay, there are two shifting properties. F of e per iax f of x equals f of alpha plus a. So first one, first write the definition. What is the definition of Fourier transform? F of x 1 by root of 2 pi integral minus infinity to infinity f of x e power I alpha x dx. So what is the start with the definition? Whatever be the thing, whether it is a theorem or a problem or a property, start with the definition of Fourier transform. F of x is 1 by root of 2 pi integral minus infinity to infinity f of x e power I alpha x dx. So now what is asked? What is the first one? F of x minus c. So replace f of x by x minus c. So 1 by root of 2 pi integral minus infinity to infinity f of x is replaced by f of x minus c e power I alpha x dx. Then you take t is x minus a. So dt is dx. Take t is x minus a, dt is dx. So as x varies from minus infinity to infinity, t will also vary from minus infinity to infinity. So, in 1 by root of 2 pi, we are rewriting this integral in terms of t. So, integral t equals minus infinity to infinity f of t e power I alpha. What is x? T plus a. If t is x minus a, what is x? T plus a. So, e power I alpha t plus a. What is dx? dt. So I repeat, this integral is replaced with respect to t. X minus a is t, so f of t. E power I alpha, if t is x minus a, x is t plus a. So e power I alpha, t plus a, dx is same as dt, and t also varies from minus infinity to infinity. Now you see the integral. I alpha dt is the variable. You split the exponential function e power I alpha t into e power ia alpha. So t is the variable. So e power ia alpha is a constant. Take it out. So e power ia alpha times 1 by root of 2 pi integral to t equals minus infinity to infinity f of t e power I alpha t dt. So we have split the exponential function. T is the variable. So the constant term is taken off. E power I alpha 1 by root of 2 pi integral t equals minus infinity to infinity f of t e power I alpha t dt. So now you see this is a definition of Fourier transform. You see the definition. Always you should have the definition in your mind. What is the transform of f of x? 1 by root of 2 pi integral minus infinity to infinity f of x e power I alpha x dx. So in place of x you have t. So this is the definition of Fourier transform. In place of f of x, you have f of t. In place of dx, you have dt. So what is the constant alpha? So e power ia alpha, f of alpha. So the Fourier transform of f of x minus a is e power f of alpha. So this is the first shifting property. Second one, f of e power iax, f of x equals f of alpha plus c. Start with the definition. F Fourier transform of f of x is defined as 1 by root of 2 pi minus infinity to infinity f of x e power I alpha x dx. So in place of f of x, you have e power iax f of x. So 1 by root of 2 pi integral minus infinity to infinity e power iax f of x e power I alpha x dx. So f of x exponential term is grouped e power I alpha x plus iax e power iax dx. The exponential term e power I alpha x into e power iax is same as e power I alpha x plus iax. You should have to add the powers. Then 1 by root of 2 pi integral minus infinity to infinity f of x e power alpha plus a into x dx. So e power ix is common, alpha plus a in x dx. So now this is the same as a definition of Fourier transform. In place of if alpha is a constant, it is written as f of alpha. Here in place of alpha you have alpha plus a. So f of alpha plus a. So this completes the second shifting property. I repeat, start with the definition. F of x transform of f of x is um, written is defined as 1 by root of 2 pi integral minus infinity to infinity f of x e power I alpha x dx. So in place of f of x, what do you have? E power iax f of x. So 1 by root of 2 pi integral minus infinity to infinity e power, what is f of, in place of f of x, you have e power iax f of x e power I alpha x dx. So f of x into, we are grouping the exponential terms. So we are adding the powers e power I alpha x plus iax, that is e power I times alpha plus a into x. Ix is common, so alpha plus a x dx. So if alpha is a constant, we write it as f of alpha. If alpha is a constant, we write it as f of alpha. I told you any Fourier transform has two notations. If alpha is a constant, it is written as f of alpha. Or it's written with respect to function f of x, either f of x or f of alpha. So in place of which is a constant here, alpha plus a, so f of alpha plus a. So that this completes the second shifting property. Transform e power ax f of x equals f of alpha plus a. So I will continue with the explanation of other properties in the next lecture. So you listen to the lecture. As you listen, you write every step in the notebook. Then only you will understand you write it down and then understand. Otherwise, you will not find it easy. I'm telling you this in many classes. As you listen to the lecture, you write each and every step in the notebook. You will find it easy to understand. Still, if you have doubts, you can ask me uh, at any time. So I will continue with the explanation of other properties in the next lecture.